Hi everyone, this is Mrs. J, and today we're going to be talking about the applications of quadratic equations. But first, please pause the video and give this warm-up a try. All right, go ahead and check your work here. So this is just a review of what we learned last lesson, solving quadratic inequalities. So first we solve the inequalities as if they're equations. So this tells us where our equation is equal to 0. So you can see I did that for both of them by factoring. But we want to know where it's greater than 0 for the first one and less than or equal to 0 for the second one. So we need to do a sign analysis. So I used the factors and I found the signs of the factors over the different intervals, allowing me to find the overall sign of my function. And then for the first one, we have two separate intervals where our answer is positive, so negative infinity to negative 9 halves and 9 halves to infinity. But for part B, we want to know where our equation is less than 0, so the negative portion, which is between and including 1 and 3 over 2. So today we are going to be doing word problems that involve quadratic equations. So there's a few different common types of word problems you'll see. So let's get started with this first example together. So this says 8 more than the square of a number is the same as 6 times the number. Find that number. So for many of these problems, we're going to have to make our own equation, which means we need to pick a variable, and anytime we're using a variable, we need to define it. I will be pretty picky about that. So if they're asking us to find that number, we're essentially going to use the question to help us define the variable. If they want us to find the number, x is going to equal the number. And yes, I will require that you physically write what your variable is equal to. So now that we've defined our variable, we can start translating from English into math. So let's look at this first phrase together. 8 more than the square of a number. So let's start with the square of a number. Well, the number we've decided to call x, so the square of a number is x squared, and then it says 8 more than that. So x squared plus 8, or we could have said 8 plus x squared. So now we're to the word is. Anytime you see the word is, it's going to mean equal. So is the same as, or maybe it will just say is. So again, we'll have an equal sign for that. And then it says 6 times the number. Oh, well, that's just 6 times x, or 6x. So now we have the equation, and now all we need to do is solve, which we know how to do. So I'm going to start by setting my equation equal to 0. Luckily, this is an equation that we can factor, x minus 4 times x minus 2. Remember, never lose your equal sign as we go along. We'll do a little zero product property. And we have x equals 4 and x equals 2. So in this case, there are actually two numbers that satisfy this set of conditions. So in this case, we actually have two answers. We should look back at the equation or at the original problem and make sure our answers make sense. Like maybe in some contexts it wouldn't make sense to have a negative number and you get a negative answer. But in this scenario, both answers would make sense. You can go back and double check that they work, and they do. So in this case, we have two solutions to this problem. All right, let's try this next one together. This says the product of two consecutive odd numbers is 195. Find the two numbers. Okay, so here we are finding two numbers, but when we have an equation, we would really just like to have a single variable. So I'm going to pick the variable x again. And, well, we're finding two numbers, so you could either define x as the first number or the second number. So I'm going to define x as the first number. Okay, so let's see if we can work through this first phrase. The product of, so we're going to be multiplying two things. Two consecutive odd numbers. So we know that odd numbers are always 2 units apart, right? 3 to 5, that's 2 units apart. 7 to 9, 2 units apart. And consecutive, you'll see this a lot. Consecutive means the next one in line. So if x is the first number, that means that x plus 2 must be the second number. Because again, they are consecutive, so it means it's the next one, and they are odd, which means they're always going to be 2 units apart. So now we have a way to define both of them. So now we're going to take the product of those two numbers. So we have x times x plus 2. So we're done with that first part of the phrase, the product of two consecutive odd numbers. And then we see that word is again, so that's going to mean equal sign. And then we have 195. So now that we have our equation, now all we need to do is solve. And this is a quadratic because if you multiply out the left side of our equation, we have that x squared term. So from here, I'm going to set my equation equal to 0. Now, this equation actually is factorable. It might not be as obvious, so you could always resort to the quadratic formula if you're not sure. But you do have your scientific calculator to work with, so you can test some different numbers. So what multiplies to make negative 195 and adds to make 2, we can do positive 15 and negative 13. So 15 times 13 is 195. And again, if you don't catch that, you could always use quadratic formula and you will get to the correct answer. Okay, and then a little zero product property will help us finish solving. So we have x equals negative 15 and x equals 13. Okay, so here again we have two sets of answers. Our answers are not negative 15 and 13. Remember, x only represents the first number. So one set of numbers that could work would be negative 15, and the next consecutive number, or odd number, is actually negative 13. And you can check if you multiply those two numbers, it does equal positive 195. And the second set of numbers, well, the first number could be 13, and the next consecutive odd number would be 15. So it'd be positive 13 and positive 15. This may have been something that you could have figured out just by kind of guess and check. You could just pick two odd numbers and start multiplying them until you get closer to 195. However, I will absolutely expect you to be able to create an equation and solve that equation to answer these types of problems. So again, you could always, double check your answers, or you could use logic to help you get a start, but you do need to know how to model a scenario with an equation. All right, I have one for you to try on your own, so please pause the video and give it a shot. All right, go ahead and check your work. The first thing I want you to check for is that you defined your variable. You have to do this, so if you don't have this, please add it into your notes. And then check that you have an equation that models this scenario. So it says if a number is added to twice its square, 2x squared, the result is 6. And then from here, you can solve however you like. I solved by factoring, and here we actually get two numbers that would work for this scenario. All right, so now we're going to move on to a different type of word problem that you'll see a lot with quadratic functions. And this is modeling projectile motion or modeling the height of something that is falling. So in these types of problems, it's really common that you are given the equation that models the height of this object. So here we may not be actually making the equation, but we do need to use the equation to help us answer different questions. So let's try this first one together. A water balloon is catapulted into the air so that its height, h, in meters, after t seconds is h equals negative 4.9 t squared plus 27t plus 2.4. So the first thing they're asking us to find is the initial height of the water balloon. So this is a really common thing that you'll be asked to find. So we need to know what initial means. Initial means the starting height. And then we need to infer a little bit from there. If it's the starting height, that means it's the height when t equals 0, when the time is 0. So initial is always going to be when the time is 0 or at the beginning of your experiment. So all I need to do to solve this problem is find h of 0. So we're just going to substitute 0. So that's going to be a pretty easy thing for us to do in our heads. 27 times 0 plus 2.4. So we see that h of 0 is just 2.4. Now it is a word problem, so we need to make sure our final answer has units. So this one we're going to say 2.4 meters. It's very important to go back and look at the original problem to get your unit. So we're going to be in meters for our height and seconds for time. The next question they ask is how long, so here this implies we will be solving for t in some way, does it take for the balloon to reach its maximum height? So anytime you see the word maximum or minimum and you're working with a quadratic equation, we know that that's always going to be associated with the vertex. So we are going to be finding something about the vertex, but the vertex has two parts. It has an x value and a y value. So since it's how long, which is that t value, or it's your independent variable, here we're essentially asked to find the x value of your vertex. So again, the word maximum or minimum will always imply vertex for quadratic equations, and then you just need to figure out what part of the vertex answers your question. So here, let's find the x value of our vertex. So we do have a little formula to help us with that. Negative b over 2a will help us find the x value of our vertex when it's in this form. So negative 27 over 2 times negative 4.9. So this we can plug into our calculator and get a decimal approximation. Please make sure if you're doing it all in one go that you group your denominator. If you just do 27 divided by 2 and then times 4.9 with no parentheses around that, it will not treat 4.9 like it's in the denominator. So you have to be very clear about that to your calculator. And here, let's just round our answer to the nearest tenths. So we have x is about, so you get 2.755. So if we round to the nearest tenth, that'll be 2.8. And since it is asking how long, we do need to use the correct units for our independent variable, which is seconds. All right, next part they ask, what is the maximum height of the balloon? So again, we see that word maximum. We know that that's the vertex, and in this case, they don't want to know how long it takes to get there. They actually want to know what is the maximum height. So here we actually want the y value of the vertex. So what we're going to do is we're going to we'll take our approximation from the last answer, 2.8, and we'll plug it into our equation. And this we can also, we'll use our scientific calculator to get, and we'll round it to the nearest tenths again, give us a decimal approximation. We get 39.584, so that would be 39.6, and make sure we include our units of meters. So again, you will see the word maximum or minimum a lot with these types of problems, so that should scream vertex to you. When you see those words, it's some part of the vertex, so either the x or the y value. All right, this last one asks, how long does it take? So how long, again, we are going to be solving for x, or the t value, for the water balloon to hit the ground. So here we also need to infer a little bit of information. If something is hitting the ground, that's when the height is 0. So we essentially need to set our height equal to 0, and then we need to solve. So we have 0 equals negative 4.9 t squared plus 27t plus 2.4. So there are a few different ways we could go about solving these. Pretty much when the numbers are not very nice, I like to just go straight to the quadratic equation. We can use our calculator to help us get a decimal approximation if we need. So let's do that. So we have x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times your a value. So here, if you are plugging this into your calculator, it's best to try to do it all in one go. That can be a little bit tricky, but if you're careful with how you group, specifically grouping the numbers in your denominator, making sure there's parentheses around it, and making sure that all of this expression is inside your radical, you should be able to do it all in one go. So please try to do that. So if you do the negative 27 minus your radical, you will get a negative answer for this. So that first one, if you round it, again, you get negative 0.087, so negative 0.1. Now, for our problem, a negative answer won't make sense because our x value, or our t value, represents time, and there's no such thing as negative time. So this won't be a solution for us with the context of the problem. So we do need to do the other one, the plus our radical. And for that one, we would get about, if I'm rounding, 5.6. So this does make sense for the context of our problem, so this will be our only solution. So t or x equals 5.6 seconds. So again, these are super common types of problems that you'll see with quadratics, and it really is just about interpreting what they're asking us to find. Initial height is when t is 0. We could also think of this as the y-intercept. That's what happens when x is 0. It's the y-intercept. Anything with max or min, we're finding part of the vertex. And if we're looking for when something hits the ground or whenever the height is 0, we are essentially solving for the x-intercepts, or the zeros of our problem. And it is also going to be very common for us to use our calculators to get decimal approximations. So don't panic if your answer is a decimal for these problems. All right, here I have one for you to try on your own. So please pause the video and hit play when you're ready to check. All right, go ahead and check your work. So for part A, we're asked to find the initial height, which is the height when t equals 0, also the y-intercept. So we can find that by replacing our t values with 0, and we get 58.8 meters. For part B, it says how long does it take the rocket to reach its maximum height? So we are finding the x value of the vertex, which is exactly 2 seconds. And then it asks what is that maximum height? So here it will be the y value of the vertex, because remember the y value represents the height of our rocket. So I plugged it back in and we get 78.4 meters. And then for part C, or sorry, this should say part D, how long does it take for the rocket to hit the ground? So we want the x value when h is 0. So we're essentially finding the x-intercepts. You can absolutely do this with the quadratic formula. It's probably what I would do first when we have not as nice numbers to work with. We get two answers, -2 and +6. So the negative answer doesn't make sense for the context of this problem because there's no such thing as negative seconds. Now this one is definitely not obvious, but there is a GCF of -4.9 in this equation. So if you factor that out, the rest is pretty easily factorable. So you could also solve in that way. Okay, the last type of problems we're going to be working with, I call them area problems. So let's give this one a try together. This says a rectangular lawn measuring 8 meters by 4 meters is surrounded by a flower bed of uniform width. So you can see here's the lawn, and then around it is that flower bed that has a uniform width. The combined area of the lawn and the flower bed is 165 square meters. What is the width of the flower bed? So we need an equation to model this. So we need a variable to define. So I always look to the question. The question is, what is the width of the flower bed? So I'm going to define x as the width of the flower bed. And whenever possible, your variable, when you define it, it needs to include units. So this one is going to be in meters. because all of the units in the problem are in meters. So x is the width of the flower bed. You have to define your variable. So that means that this distance is x, this distance is x, and so are these distances. Okay, let's see what else we know. It says that the lawn part measures 8 by 4 meters. So this distance from here to here, this is 8 meters. And we know this distance from here to here is 4 meters. And then it says the combined area of the lawn and the flower bed is 165 square meters. So we know that this is a rectangle, and we know that the area of a rectangle can be found by doing the length times the width. So we need to find a way to define the length and the width in terms of our variable. So if you look at this length from here to here, we'll look at the different parts of our length. We have x plus 8 meters plus x. So this total length becomes 2x plus 8. And then if you look at the width of our rectangle, and you look at the different elements, from here to here is x, and then plus 4 plus another x. So this distance would be 2x plus 4. So now we have a way to define the area in terms of x. 2x plus 8 times 2x plus 4. And we are told in the problem that the area is 165 square meters. So now we have defined our variable, we have set up our equation. Now it's the easy part. All we have to do is solve. So first we are going to want to multiply out the right side of our equation. So we get 4x squared plus 8x plus 16x plus 32. We're going to combine like terms, and I'm going to set our equation equal to 0. I'm going to try to do that in the same step. Okay, so we may be able to factor this equation, but those numbers would be a little tricky to work with. So I'm just going to move straight to the quadratic equation. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a So we have x equals negative 24 plus or minus the square root of 2,704 all over 8. That does end up being a perfect square conveniently. So we have plus or minus 52 all over 8. So now we will do the two separate scenarios. So negative 24 minus 52 all over 8, and negative 24 plus 52 all over 8. And here we get two solutions. So we get negative 9.5, and here we get positive 3.5. So again, it's very common to get two answers when we have a quadratic equation, but this is a real life word problem. We have to look at the variable and what we defined it as. So if x represents the width of a flower bed, it is not possible for an x value to be negative. So it just doesn't work for the context of this problem. So we do have a single solution here, and it says what is the width of the flower bed? X represents that width, so our final answer is 3.5 meters. And this is why I do like to make sure to define my units when I'm defining my variables, so it makes it really easy for me to write my final answer in a complete way. All right, let's try one more together. Here we have a rectangular field will be fenced on all 4 sides. There will also be a line of fence across the field parallel to the shorter side. So here we're not given a picture, so let's draw this picture. We know what a rectangle looks like, so we have a rectangular field. So it looks something like this. And then it says there will also be a line of fence across the field parallel to the shorter side. So these are the shorter sides, so that means there's going to be a line somewhere across that's parallel to that. Doesn't need to be exactly in the middle, it's just somewhere. It says if 900 meters of fencing are available, what dimensions of the field will produce the maximum area? What is the maximum area? So here we're going to need to create an equation that models the area because we want to maximize the area. And then we actually need to find that maximum value. So first thing we need to do is we need to define a variable. We need to pick something in our picture and we need to call it x. So I'm going to define this length as x. So I'm going to say x equals, I'll call it the shorter side of the field, and we'll say it's in meters because we are given that we have 900 meters of fencing to work with. Now, if I have that length as x, that means that the three parallel sides will also have that same length. But again, I need to find a way to model the area of our rectangle or of our entire field because we want to maximize that area. So we know the area is the length times width. Well, we already know that this width is x. So we need to find a way to describe this length in terms of x. So now we're going to go back to this piece of information with how much fence we have available to use. We have 900 meters of fence to work with. So we have 900 meters of fence, and then we used x here and x here and x here. So far we've used 3x meters of fencing. So we started again with 900 and we've used up 3x meters, but we have to use that remaining fence to cover these two lengths, right? But these two lengths we know are the same length. So if I take the remaining fence and I simply divide it by 2, that will be the length from here to here. So now we have a way to describe the length of our field in terms of x. So now I can model my area. So the area can be found with x times 900 minus 3x all over 2. Okay, so now we need to actually answer the question. We want to know what dimensions will produce the maximum area and what is the maximum area. Anytime we see the word max or min with quadratics, we are finding the vertex. So we need to find the vertex of this equation. So what I'm going to do is I'm going to try to simplify this equation a little bit. I'm going to divide both of these terms by 2. So we have negative 3 over 2x plus 450. And then I'm going to distribute in my x just to make it in standard form. Okay, so from here, all I need to do is find my vertex, which I know how to do. The x value of the vertex is going to be negative b over 2 times a. And here, actually, these 2's are going to cross out. So we just have our x value is negative 450 divided by negative 3, so 150. Okay, so this is actually the first part of our answers, is what dimensions will produce the maximum area. This is the x value that gives us the maximum area. So if we want to find those dimensions, well, we know that one length should be 150 meters, right? This length should be 150 meters, and then we need to figure out what this length is. And we can find that by simply plugging in 150 into this equation. So we have 900 minus 3 times 150 divided by 2. So that gives us 225. So the other length, I'll say by, is 225 meters. So these are the optimal dimensions And again, we found that by finding the x value of the vertex. So that is the optimal x value. Now, the second part of our question is, what is that maximum area? So for that, we want to find the y value of our vertex. We actually want to go back and plug 150 into our area formula. So I'm going to do that over here. So let's find a of 150. So negative 3 over 2 times 150 squared plus 450 times 150. So our maximum area is 33,750, and we want to make sure we have the right units, meters squared. For area, our units need to be squared. So this is definitely a little bit of a trickier problem. We need to be able to visualize the scenario. We need to be able to find a way to define the area all in terms of x. So this step is definitely a little bit tricky. And then we need to know how to interpret the problem to understand that they're really just asking us to find the x value of the vertex and then the y value of the vertex. All right, so I have one for you to try on your own. If you get stuck, look back at example 4 to give you a start. All right, go ahead and check your work here. We were given a picture, which can help a little bit. X is the width of the pathway in meters. It is still important to define that. So the area of the total rectangle should be length times width. So this width you could see is 12 plus x, so 12 plus 2x. And then this length would be 16 plus x, so 16 plus 2x. So that's how I created my area equation, and it says the area should equal 285 square meters. So then I multiplied out my equation, set it equal to 0, and then I used the quadratic equation to solve. The negative answer does not make sense for the context of this problem, so my only answer must be 1.5 meters. All right, here I have one more for you to try on your own. Please look at example 5 if you need a little help. All right, go ahead and check your work here. I drew my picture and I defined x as the length of the shorter side in feet. Please make sure you have defined your variable. On a test or quiz, I would take off points for not defining your variable. So if this width is x and we started with 1,200 feet, well, I know that I started with 1,200, I've used up 3x, and then I have to split the remaining fence up over 2 equal sides. So this is how you can define the length of your rectangle. So then if we want to maximize our area formula, and we want to find the dimensions, that means that we need to find the x value of the vertex. So I use negative b over 2a to find that x value, but then I only know this dimension, so I need to take that 200 and plug it back in here to find out this dimension as well. So your optimal dimension should be 200 by 300 feet. All right, that is all for today's video. Thank you so much for watching.